All right. Write an equation on the line in slope-intercept form with the given slope and y-intercept. Don't make this harder than it has to be. Okay, for this section, we're just plugging in the slope and the y-intercept. Don't make it any worse. Y equals mx plus b. Done. Whenever you see the term slope-intercept form, it's always that y equals mx plus b equation that we're just plugging in there. So no worries. And that's all you do for the last two on here. When we get down a little further. Now here, I want to thicken up my axes a little bit. Yeah. You could. That's a good point. Let me come back up to that one for a second. I'm glad you mentioned that. On number 3, I could do y equals mx plus b, but 0x means I really don't have any. So I could absolutely just write y equals 6, and that'd probably be the better way to go anyway for that one. So when I get down then to 4 and 5, and again, I'm trying to give you some assistance even up above in what you need to do. So for 4, it says, A, we need to find the slope. So if I find the slope, I need to figure out how far it is to get from one point to the other. Now again, depending on which way you went, some of you may have gone down and right. I chose to go up and left. You'll get the same answer at the end. So if we go my direction here, I went up 1, 2, 3, 4, 5, 6. If I go up 6, is that positive or negative? That's positive. But then I have to go left 1, 2. Is left positive or negative? Left is negative. So my slope, my part A, 6 over negative 2, because that's my up or down number, my rise over my run. Which is the negative? Nope. Because what's 6 divided by negative 2? Negative 3, okay? So that's my m. I had to calculate it this time from the picture. Once I get my m, now I go back in. It says find b. Plug a point into, okay. So b. I can use either one of the 2 points here. Doesn't matter which one. I'm just going to use this one. I like 0. So I know my m is negative 3, and I have this point 0, 2. And that point tells me x and y. Just like what we were doing yesterday, I'm going to plug numbers in everywhere that I have a value available to me. So I know x, I know y, I know m. I'm going to plug all 3 of them in. So y is 2 equals m x plus b. The only thing I don't know is b, and that's what I'm trying to find. It is, because anything times 0 is just 0. So that basically just goes away. Nicely done. I was going to say, some of you notice, well, that's my y-intercept. I see it on the y-axis anyway. Good. I could avoid doing this even if I'd have noticed that right away. And then finally, write the final equation. All right. Y equals mx plus b. Boom. Yes, it's a process. But yes, when we get to next week and we're doing the review and then we're doing the test on this, what you're seeing right now as far as help on what the steps are goes, that's exactly what we're going to be doing then. So my biggest point to you is going to be this. Make sure when we're doing a review like this, I don't think so. You get your other one? Okay. And we're going to be doing reviews like this again next week. I'll have the instructions there for you. I'll even have the arrows. So you just got to get used to kind of working through the process and really paying close attention to the detail work that we're doing. So that's how we work this midsection. If I scooch up a little more, draw the graph of the line. Now again, we've got directions up here. So if this is one you're an expert on, keep busting through. If not, we'll kind of see what's happening here. Let me darken up my axes a little bit more. This is an area we've had a little bit of an issue with. So just give me this. Which one of those numbers is my y-intercept? -3. So that's what I want to do first. So if my y-intercept's -3, yes, sir. And we will in just a minute, yes. For my y-intercept, though, since it's a negative, what direction am I going to be going 3? Down. Okay, because here's my y-axis. My choices are up or down. So since it's negative, we'll go down 3. And then, Eric, you had a good point here on the slope. I could, and that's another thing let's talk about. I like the way you guys are thinking today. Because, right, I can always make slope a fraction by putting it over 1. So if my slope was -2 over 1, what directions would I be going? Correct. Be going down 2 and right 1. Now, Michael brought up an interesting point. If I wanted to make more points to make my line more accurate, I could put the negative on the 1 instead. So if I switch the negative and positive, it's the same value. Right. That's going to change this to up 2 and left 1. And I'd be able to make more dots to make my line more accurate. Yeah, we've got to put the line through with the arrows, because the whole idea is we're graphing a line, and if I don't connect them, I'm just plotting points. We're not just plotting points. We want to make sure we get that line in. So again, if we do that one more time on this next one, here's what I want you to do. Don't say anything. Take a moment. If you haven't done number 7 yet, try it using number 6 as your guide. We'll get the answer up in just a minute, but I want you to take a second and see if you can get that line graphed. See if you can make it work on yours. Just remember, the y-intercept you're graphing first. And once you get that y-intercept put in there, then remember the angle by itself is quick peek here. I saw lots of good ones. Y-intercept is down 2, and then from there, we're up 3 and right toward. Make my other dot from there. Okay? So I'm feeling a little better here. Feeling a little better. So much better, as a matter of fact, that we're going to throw a new thing in here while we're doing the re-review. You're like, wait a minute. My line is, I see that. A little bit of a twist. I think I might need to start busting out the ruler here. Start making these a little straighter. You're like, oh great, word problems are coming. All right. Wade's grandmother gave him $100 for his birthday. That was nice. Wade wants to save money to buy a new MP3 player. Oh, he's behind the times. Each month he adds $25 to his savings. Write an equation in slope-intercept form that describes Wade's savings. Okay. Two things we got to keep in mind: the $100 and the 25. Nice, okay? Because how we do that, and again, Marcus, nicely done. Okay, here's how this works. The $100, is he going to get that one time or is he going to get it monthly? Okay. He gets this money one time. But this he gets every month, right? So if I'm trying to describe on a monthly basis what Wade's getting, yeah, the one that changes all the time gets to go with X, because depending on how many months it's been, if it's been 3 months, I'd plug in 3 for X. If it's been 10 months, I'd plug in 10. But the money his grandma gave him is one time, so it doesn't get X. And that's all I do for those. This is where we make an application of things. That's all I have to do. It's not bad. It's not bad. And it's a story problem. It's not bad. Amazing. So let's look at that on the next one and see how we've got this working. Oops, I'm down here a little. Okay, remember, one of those numbers is one time. Okay, 40 would be D for days. So this is my one-timer. And again, if you used X, though, that's fine. That's fine. So 40D plus 20. Well, I'll find out later if you get it. All right. It can be X. Yep. All right. Next section. Write an equation in slope-intercept form. Okay. Just like we were doing on the front, we're going to plug in to ym and x because I know the slope, I know x and y. So let's see what this is going to look like. So I have y equals m x, yes, plus b. Okay, here comes the fractions again. Remember, if you have a fraction, don't panic. We're going to take the fraction. We're going to turn that 6 into a fraction. Because once I do that, now I can just, multiply straight across, and that number will come out nice. So I just replace that with -4. And what's my one step to get b by itself then? How do I get that -4? What's the opposite? Add 4. Gotta do the opposite. Yes. Well, if you minus the negative, it would be. So I have this, but now my last part, oh my, plug in out. No, plug into y equals mx plus b. So y equals, my slope, already gave that to me, mx plus b. Keep life simple. I know, sometimes that can seem hard, but for what our purposes are, not bad. Okay, let's actually do 11. Same idea. My first step, I have m, I have x, I have y. Just follow where the arrows go. y equals m x. What? We're going to. Nope, we're going to. Oh. He's like, ooh, I better start writing down the stuff we're doing. 4 times 3 is 12. And again, what's my one step to get b alone? Okay, the opposite of adding 12 to b is to subtract it. So that's my b. But my equation then is y equals m x plus b. And I can put plus -4, or I can just put -4. And that's my answer. And again, for some of you, it's a process. I mean, I'm substituting, I'm solving an equation, I'm substituting again. It can be, but that's why I'm trying to kind of give some guidance here on where everything goes. Yes, it would. For the bottom portion here, again, we're just looking for slope. So we're just counting up and over. Okay? Keep it simple. 1, 2, 3, 4 up is positive. 1, 2, 3 right is positive. But here's a reminder. You have to write this as a fraction. I don't want 4, 3. This isn't a point. Okay? We've got to put it in there as a fraction. And the y value, my up or down, has to go on the top. I can't flip them. They're not interchangeable. Just like, for instance, on number 5, if we were looking at it. Let's say I decide I'm going to go this way, and then I'm going to go this way. I went down 1, so that would be -1. But I went right, 1, 2, 3, 4, so that's +4. -1 over +4. My up or down number always, 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 always goes on top. So that's where it goes. Okay? Oh, we're heading down the home stretch. One more flip. Looking around, make sure I'm safe to flip. It looks like I'm safe. Almost. Okay, tight here for a second. Let's see if 4 sets of eyes still looking. Ah, number 6. Yep, number 6 is 0. So we have the horizontal line. I wish I had Mr. Slope guy here. I'd whip him up on the screen right now. Alright, to the back. Here is the formula we need. So all we're doing for slope, and here's one thing I'm going to beg of some of you. Before you start doing this, label your points. Because some of you, when you're doing slope, some of you are doing y and x, and sometimes you're using the same point twice. If you label them right away, and right away I put my minus in here, in my formula, less likely I'm going to have a problem. So like here, I'm like, okay, y2, that's -1, minus y1, all right, that's 7. Then x2, that's 3, x1, that's -2. Because most of you, once you get to this point, you do a good job. It's just, can we get to here? So let's see. I owe my friend $1. I borrow 7 more. How much do I owe now? I owe 8. But here, minus a negative, the double negative causes some good. Remember, minus a negative to make that plus. So 3 plus 2 is 5. And that one doesn't reduce anymore. This is just basically testing our skills with adding and subtracting. And if I got to go to the calculator for backup, I do. Okay? Don't let that worry you. Don't get scared about it. Let the calculator do its thing. And finally, Finally. I actually want to do all of these because, oh, well, I'll hang right in here for a second. Okay. Yes, depending on how I did my x's and y's, I could end up with a -5 and a positive 8 as well. Yep. That's absolutely okay. Yeah, if you did y1 minus y2 and x1 minus x2 and got 8 over -5, that's actually the same answer. That works absolutely fine. Okay? Now, when you get to the last three, you have a choice. You can either get y on the side by itself, or you can use the intercepts, where we make the other variable disappear. For instance, let's say we decide on 22, well, x and y are on the same side already. Let's just use intercepts. So if I do intercepts on this one, and we'll do some of both, just so you can kind of pick which way you like doing it. If I'm doing the x-intercept, pretend y doesn't exist. And I write what I see. Oh, x equals 5. Okay, that was kind of cool. One step and done. Then I do it for the y-intercept. I cover up x. It doesn't exist anymore. Negative y equals 5. But I don't want negative y. I want to know what y is. What's my one step to get? Okay? Because here, since I'm multiplying it by -1, I divide it by -1. Yeah, I was going to say, it can depend. Sometimes it can be. So my x-intercept is at 5. Here's my x's. So I go right 5 and I put a point. And my y-intercept is -5. So I go down and I put a point. Okay, it's different from slope. I just plot the 2 points. I'm done. And that's okay. Absolutely. Because some of you are saying, well, this takes more time. I got to make separate equations. I got to solve it. What's my other option? My other option, yes, to get y by itself. So if I do that for 23, okay, I want to get this by itself first. How do I get the plus 12 out of there? Minus it. So 8x minus 12 equals -4y, but I want y total. So since I'm multiplying it by -4, I'm going to divide everything by -4. -2x plus 3, that's what my y is. And now I can use that equation to graph my line. So let's see, which one of those numbers is my y-intercept? So that's my y-intercept. So if my y-intercept is 3, what direction am I going 3? Up, because it's positive, and I go up. I put a point. Then, what's my slope? Okay, so what's that mean if that's my slope? Down to the right one. And I can do that a couple of times. Down to the right one. Either method would work on these. Doesn't matter which one I choose to use. So the same thing would be working on this last one. If I chose to do the y equals part, box that in. I'd minus my 12. And I would work on getting y alone, like I did on the last one. 6 divided by 3 is 2. -12 divided by 3 is -4. And again, when I go to graph, the number hanging out on its own is my y-intercept. Down 4, put a dot. Make my slope a fraction. Up and right. Up 2, right 1. Put a line on through. I know. It was. So your job with the ones that we've done together is to finish this one up. I don't think no, not everyone. I slowed down in a couple of places enough that I think some of